Hi, everyone, and welcome to our new stream for the month of March. I think this is our first stream in the month of March. It's only second March, of course, not a big deal. But anyway, so I'm really looking forward to this one because I think this is a very important topic, and this is something that our team at AppSecEngineer has been playing with for some time now. So we thought, why not make a stream around this? I thought, why not make it, something that I would figure out myself, because this is something that I've tried to figure out myself. I've tried to understand this in a little bit of detail. Initially, it was a little difficult for me to grasp, although it's quite simple. But as with me, I always like to go one level deeper and see what's actually happening under the hood. So that for me was a little difficult to understand initially. But once I looked at their documentation and resources and things like that, uh, I was able to figure this out. And it was quite useful. I'm not saying I'm an expert at it, but it's definitely something that I have enjoyed working with. So, what is that we're going to be talking about today? Today, we're going to be talking about surprise, surprise, supply chain security. So, as if everything else in security was not always about supply chain security, this topic is also about supply chain security. But I'm not coming to you with a supply chain attack or a supply chain exploit. I'm coming to you with a way to actually deal with this situation, right? So, one of the big problems with supply chain, as we typically see with a lot of supply chain news out there, is that, oh my God, it's all pretty much broken, and it's all we don't have too many ways out. Of course, there are a lot of tools, and there are a lot of commercial tools, there are a lot of open source tools, but uh, it's hard to separate the signal from the noise, right? There's a lot of noise around supply chain as well. Now, this is something that we'll be doing a class on. In fact, we're going to be doing a training and course on the topic that I'm going to be talking about today. In fact, it's going to be probably launched in April. It's work in progress, but we're probably going to be launching this in April along with a whole bunch of new courses. In case you're wondering what I'm talking about, I'm looking. I represent a company called AppSecEngineer. We do a lot of online training, and we have an amazing online training platform that has hands-on labs, and you can get some real cutting-edge education around Kubernetes, AppSec, DevSecOps, threat modeling, what have you. Anything in AppSec, anything to make you a better AppSec engineer. So do check us out at some point in time. Today's topic, though, is going to be about using a project called Cosign. Cosign, the reason we're going to be using Cosign is to secure our supply chain, specifically container images and binaries, right? So it's not only container images, although containers are a very important part of the supply chain, and some would say the dominant part of the supply chain in today's day and age. We're not only going to be talking about containers, we're going to be looking at the overall problem, and we're also going to be looking at binaries, because believe it or not, binaries are also an extremely important aspect of supply chain. Imagine you're installing something, you are deploying something, you are using binaries, and those, or you might just be downloading something off the internet. That is something that you want to make sure is secure, or is at least who it says it is, or it's been built or developed or signed by who it claims to be from, right? So you want the authenticity, you want to make sure that it's the actual entity or the person or the organization that is that is signing that, or is making sure that that is an authentic artifact or a binary or a blob or a container image, right? So let's talk about the problem first. Now, this is going to be a slightly different. I don't have a slide deck or anything like that. I'm going to be using mostly like mind maps to explain this. So let me just start sharing my screen, and let's look at some mind maps to actually understand the space, understand the problem, understand the space. I'm going to just blow it up a little bit, not so much, maybe just a little bit. Yeah, here you go. This is probably, okay, just gonna use, yeah. So let's bring this into focus, right? Now, if you look at supply chain attacks, you have a lot of these. These, what I've listed out here, are just a few of them. They're not obviously all encompassing, but these are some of the key ones that you would see, like key compromise, GPG keys getting compromised, or you think that it is this person's GPG keys. Let's say you think that it is Linus Torvalds' GPG keys, and it ends up being somebody else's GPG keys, right? So key compromise, basically, which is on trust on first use systems, swapped hashes and artifacts. Now, this is actually a very common thing. So you have hashes. So let's say you're downloading Linux Mint or Ubuntu or whatever it is, and it has a hash value, along with the download. Now, let's say somebody compromises the website and changes out the hash, changes out the underlying artifact. You're downloading a tainted artifact, and of course, this is very common because at the end of the day, all of this is just hosted on the website. There's no real you're trusting that the website that somebody has is impervious to attacks or is at least secure against attacks. Whereas somebody who is just an errant web administrator could end up changing it and causing all kinds of problems that could impact a million or millions of systems worldwide. Compromised build systems, we're seeing a lot of that. Let's say you're building it on Jenkins or something like that, or you have your existing build systems with Maven or something like that, and that process gets compromised. Let's say an attacker is able to inject some kind of a binary into that process, or during the build process itself, there is some kind of malicious code that's running along with it. So all of those things are also build systems being compromised. Resource hijacking is typically, in fact, this is a very interesting attack. I didn't know of this before. I actually saw a bunch of videos on YouTube. So apparently what happens is that a lot of folks just push pull requests, just create pull requests into very popular repositories. And a lot of times these pull requests, they're not automatically accepted, but there are CI jobs that automatically run, like, code quality stuff and things like that, that automatically run as soon as it receives a pull request. And when that happens, what happens in a lot of cases is they try and run Bitcoin, cryptocurrency miners and things like that, so that it at least runs for the period of time when that particular CI job is running. So a lot of times you will see that it's not always that it's this super complicated supply chain attack that happens. Something as simple and as apparently stupid like this can also be a pretty big supply chain flaw. So this is something that has been happening. In fact, this is something that we're seeing outside of this. Of course, the more traditional curl sudo bash kind of stuff, right? So you want to download something, you just curl it and then you bash it, you pipe it to a shell and run that. So you don't know what's in that script, you don't know what's happening within that script. It is another major source of supply chain vulnerabilities or supply chain issues that you might be dealing with. And of course, the classic typo squatting, right? So typo squatting is something that all of us we've seen, right? So we've seen this with Node, we've seen this with Python. I think we've seen this with Rust as well. I'm not so sure about that, but definitely Node and Python. We've had like very similarly named packages that a lot of people have downloaded, and the similarly named package to a very popular package ended up having a lot of malware. So that's basically what you call typo spotting. So instead of Python date utils is a very popular library. Instead of using date utils, somebody creates a package called date-utils, and that is vulnerable. That is malicious, right? So you have all of these different supply chain attacks. Now, one of the things that one of the things that we want to do is to validate authenticity, right? That was one of the initial premises of what I said. We want to validate authenticity. And when we want to validate authenticity, we want to do it in a way that's actually usable. Now, this is something that sounds easier than it is. This is something that's not new. Like, people have used GPG, they've used hashes for this particular purpose. But the problem is that either these technologies have been trivial. For instance, just using a hash, like I said, with swapped hash and things like that, is not super robust. It doesn't have too much of a cryptographic backing and things like that. And GPG, let's face it, GPG is a pain to use, right? If you've used GPG, you'll realize that you'll feel like bashing your head on a table by the time you actually end up using GPG. So using GPG is a pain. And again, there is also a lot of implicit trust placed on that GPG key that you find on that particular website. So there's a lot of those things that you inherently have to deal with. Now, what I liked about Cosign as the project, and that's the subject of what we're going to be dealing with today. What I liked about Cosign is they've not tried to reinvent the wheel on everything. What they've done is they've used existing tech that works well for either identity or signatures and things like that, and they have merged this and they've made this into an ecosystem of products that can solve this problem quite comprehensively. It's very creative. the approach that they have taken. They've not essentially tried to reinvent the supply chain signature or the supply chain provenance or authenticity model. What they've tried to do is use different technology pieces like Merkle trees and transparency logs and signatures, and of course cloud-backed key management systems and so on and so forth. They've taken all of these well-known constructs and concepts and built it into an ecosystem of products that is pretty powerful, right? So this is what I'm going to be looking at today. I'm going to be figuring this out from scratch, right? So this is something that I am not. I mean, I know Cosign. I've worked with Cosign, but I'm not an expert in Cosign. So this is something that I'm going to also be figuring out with all of you. So you can feel free to follow if you want to download Cosign on your system and work on it. That's up to you. All right. So I'm going to get started with this. So I'm going to open up terminal here, and I am going to start interacting with Cosign. I already have a Cosign binary, so let's actually, I'm going to just cover this up so that it does not distract all of you on screen. Now, what I'm going to do is, I'm just going to create a directory called Cosign, and I'm going to cd into Cosign. Right. Now, the first thing I want to do when I'm dealing with Cosign, let's look at Cosign's capabilities, right? So Cosign has a whole bunch of capabilities. I've just highlighted some of the key ones that I found to be very immediately useful for somebody who wants to deal with this project. I'm sure there are, and I'm quite sure because I've seen it, that they have a lot of capabilities. You can sign container images, you can sign blobs, binaries with key pairs. So it essentially uses public-private key pairs, right? So you use key pairs to be able to sign and verify the signature. So just like any other digital signature, you have key pairs that will sign and verify the signature. Cosign also integrates with key management systems like Vault and Amazon KMS and GCP and so on and so forth. In fact, I'll try and do a demo of the Vault example as well, but it integrates with that. The other cool thing that I'm not going to be able to show you this time around, but it is a amazing, quite a game-changing feature that they have, is something called keyless signature, right? So they have something called a keyless signature where it generates these short-lived keys, and it stores it on a transparency log. With the fact that it signed a particular package is stored on a transparency log. Think of it like a shared ledger of sorts, or a single source of truth, where somebody can validate that particular signature against that particular transparency log. So even if you don't have a key, you can validate and check whether this is signed by this particular entity. And since it's on a transparency log and the transparency log is immutable, you can't really do, you can be sure that that is a authentic signature, and that's an authentic artifact or container image or whatever it is. This is really cool because they use the concepts of identity with OIDC, and they also use the transparency log concept to make it a really powerful thing. I'm not going to be able to show this because I have to set up OIDC. I mean, I have to use their OIDC service, and I have to use OAuth and log in with Google and things like that. But this is really cool, and I was really impressed with the things that you can do with it. Aside from that, Cosign has a whole bunch of other things, like you can actually attach an SBOM to it. Given the impetus on supply chain security and software bill of materials, you can actually attach SBOMs. You can download SBOMs. You can attach other metadata related information to your signature and so on. So let's actually look at Cosign and see what it's doing, right? So this is the first thing I'm going to do when it comes to Cosign is I'm going to be creating a key, right? So when you do Cosign, it's basic. I think it's a Go binary. I think it's a Go binary. So if you see Cosign dash help, you'll see all of these different options. Now, what I'm going to do is I am going to first generate a key, right? So I'm going to do a generate key pair thing. That's going to be the first thing I'm going to do. Okay, so Cosign generate key pair. So I'm going to enter a password for the private key, just like you would do with any RSA, SSH key. This is pretty standard stuff. There's nothing very fancy. They're probably using some other Go's cryptographic libraries under the hood. So now I have a public key and a private key, right? So if you this is pretty standard stuff. There's nothing out of the ordinary so far. You have a public key and you have a private key, right? So now I'm going to start actually doing something with this, right? Now I'm going to sign a container image. So the first thing I'm going to do is I'm going to sign a container image. So for that, I need to enable Docker. So what this is going to do is not only does it sign a container image, but it also pushes that particular container image. I'm sorry about this. I didn't realize that my Docker had updated before I closed it. So anyway, so what not only does it sign the container image, it also pushes the signed container image over to my Docker Hub. So in this case, I'm using Docker Hub. So it's going to be pushing the signed container image over to the Docker Hub, and it also generates the tag, the Docker tag for you, which is basically a SHA-256 hash, and the signature is basically it's added as an attribute to that particular hash. So let's look at how this works. So I'm going to sign a container image now. Sign with the key Cosign. So I'm just going to sign it with the Cosign.key, which I just generated. V45 all FaaS. This is our standard. Oh, oh, sorry about that. I made a mistake with the command. Cosign sign dash dash key. Cosign dot key. Well, okay. So I'm going to enter my password for the private key. Okay, that's weird. Think signer reading key decrypt. Oh, I think I've already signed this package at some point in time. I think there's some issue with that. Uh, hmm. Yeah, it looks like it's working. I don't know why that was. Right. So you'll see that. Oh, I'm not logged in. Oh man, I need to sign into Docker Hub. Just give me a sec while I do that. Yeah, I was supposed to have been signed in. That's what I thought. Anyway, let's redo this again. It should work now. So what happens when you do live demos? Anyway, so we have this being pushed to Docker Hub. So now if you look at hub.docker.com/u/45, you will see that I have recently just pushed container image to this particular repository, which is Well Flask. And Well Flask has a new tag that has just been pushed a few seconds ago. And you'll see that this tag is very different from the previous tag. So the digest is signed and the tag has the affixed signature, right? So basically the tag is basically the affixed signature. Now, if you can inspect this, you can do a whole bunch of things. You don't have to automatically upload it as well. You have a whole bunch of modes in which you can generate it and just store the signature somewhere else and things like that. You can do all of that stuff as well. So it's pretty interesting what you can do. One of the things that you can also do is you can check whether that artifact is already on Cosign. You can actually search for that artifact with Cosign, saying Cosign triangulate V45 Alpha. And it will try and find a Docker container that is signed with Cosign. So you'll see that it actually is signed with Cosign. The reason it's been able to do that, it's able to identify this particular sign tag with this particular signature extension, right? So this is basically how you can use the triangulate command to be able to actually find Cosign signed images with your container registry. So the tooling around container registry is pretty dope, right? It's really nice because you're able to do all of these search features. You are able to reference metadata. So you can even add additional metadata objects. So let's actually try something else. So cosign sign dash key cosign dot key. You can add additional labels, right? Like Kubernetes. If anyone is from the Kubernetes ecosystem, you'll probably realize what I'm doing here. So you can version, you can add something called app v1.1.1 or whatever it is. I'm just adding something here. So this is basically me adding additional metadata parameters to my signature. So you can actually, oops, I entered the wrong password. So it's actually in that particular signed payload. So once you verify the sign, you can actually check whether this label is in, or this metadata instance is in that particular payload, and then you can deploy it to your Kubernetes cluster or whatever. So you can actually create policies around this that would say that, hey, you know what? Verify the signature. Once you verify the signature, make sure that there is a version tag applied to this, or a version metadata, metadata attribute applied to this. And if that attribute exists, only then deploy to your Kubernetes prod cluster or whatever, right? So you can actually do all of that cool stuff with Cosign. So in fact, you can actually inspect the signature, which is, let me just do that with Crane. So there's a tool called Crane that allows you to interact with a lot of different container registry tools. So let's look at the manifest. Um, so that's cosine triangulate V45 wall Flask. This is not my normal keyboard, which is why I'm kind of struggling with it. But anyway, let's see what this shows up. All right. So Crane actually gives you the entire signature, right? It gives you the metadata related to the particular signature. It says that it's an OCI image and it has this particular digest, and it gives you the annotations. It gives you all of that information related to that particular signature. So you can actually inspect the signature that is part of this particular container image that has been attached to this particular container image. The cool thing is that you don't really have to do anything extra. In fact, I don't know how many of you remember the days of Docker Notary and things like that. It's still very much there, but the support for something like that was quite limited, if I remember correctly, right? So a lot of it was highly dependent on the fact that container registries had to support it, only then it would actually work pretty well. And that was a problem because some container registries didn't support Docker Notary because of interoperability issues and things like that. So that never really took off, right? So Docker Notary and the update framework and things like that, they were great initiatives, but they never really took off. But what I like about Cosign is that it's very easy to use. You don't need to think about, okay, where is this? Is this signature interoperable with something else? It's automatically pushed as part of the container manifest itself to the container registry. And regardless of the container registry, you can use Cosign. You can use it with TTL. You can use it with Amazon ECR. You can use it with whatever, right? So it's quite interoperable in that it's part of the manifest. So I think they've solved the usability problem quite well, especially with containers. I think they've done a phenomenal job of dealing with the usability issues, right? So uh, you can actually manage that pretty well. You don't have to always upload it. You can even say upload false. So for instance, right now we're using a mode where automatically we are uploading the signature along with the container image to a remote registry, but I don't have to always do that. I don't have to. So I can just do cosine sign key cosine dot key. I think upload is equal to false. Oh yeah. uh, and you should see, I thought it prints it out on the, I'm not sure why it should have printed it out. I'm not sure. It usually uh, not on manifest cosine image signature type. Yeah, I don't know why it didn't print it out, but anyway, so you can do that as you don't have to upload this to the you don't have to upload it with the signature to the remote Docker registry. You can always use it just this way, right? Now, of course, it's all great, but how do we verify whether this actually works? So you have to use, just like you use sign, you can use verify, right? Now, when you sign with a private key, you have to verify with the public key. So it's very simple. Just do cosign.pub, and of course, public key you can publish wherever, and that is pretty standard. So once you verify this, it will tell you whether the verify succeeded or not, right? So we'll see all claims were validated, all signatures were verified against the public key, all certificates were verified against full CO root. So full CO is basically an OIDC service that they have. Let me just pull up full CO. So this is root CF for code signing. So this issues certificates based on OIDC's email addresses and things like that. So you can issue short-lived certificates. This is what I was talking about with the keyless thing. You don't have to generate keys with Cosign. You can use full CO. It generates a short-lived key. You push the signature into a transparency log, and all somebody has to do now is to basically get some kind of assurance that, hey, Abhay signed this container image. That's all they care about, right? And they need to know that for sure, without exception, that Abhay signed this particular image. Full CO and with the keyless capability, of course, and gives you the ability to actually do that quite comprehensively. So there's a really cool approach that Cosign takes to actually doing this. So it's pretty nice how you can do this with full CO as well. So you'll see that the verification as a multi-step kind of a thing. So you see that the claims are validated. You can also disable claim validation, right? So let's say you don't want, just like with JARTs, you can have claim validation and claim management, things like that. The signatures, of course, are very important, and of course the certificates that were generated that were verified against the full CO root. So they have root certificates that are in full CO. So they've kind of created the entire ecosystem, just like Let's Encrypt did, right? So they're aiming to be for software supply chain security what Let's Encrypt was for HTTPS. So I think they're really doing a great deal in actually moving that movement forward. So this is really nice what you can do with Cosign. Now let's look at another use case of Cosign. And in fact, let's look at another use case, which is essentially not signing containers, but actually signing binaries. Now, binaries, now I'm going to just create some kind of a file. I'm just going to create a txt file. It's not really a binary, but it's a file, and I still want to do some kind of a, I want to validate the provenance and authenticity of the file where I download it or whatever, right? So I just do touch sensitive dot. Let's just do simple. This is super sensitive. Needs to be authentic, and we'll write it to auth.txt, right? So we have auth.txt. Now, this is something that, so this is, imagine that it's a Go binary, or it's a file, any other file, right? Any other binary that you want, you can sign with Cosign. Now, the option that you need to use when you're doing that is essentially called sign blob, right? So instead of signing a container image, which is the default mode, sign is just container image. But if you want to sign a blob like a txt or a file or whatever, right? It doesn't really matter what it is. You could sign that with the sign blob functionality of Cosign, right? So that's what you can do when you're looking at Cosign. So let's actually do the sign blob thing. Let's sign this txt file. So Cosign sign blob. I actually did that yesterday, so it's pretty, yeah. So this is useful that I didn't have to. So I'd signed an MP3 file yesterday, so I'm just so you'll see that we have auth.txt and we have auth.txt.sig. Now, what does this mean? So we're doing a whole bunch of things. So we're signing the file, or we're signing the contents of the file, and we're generating a signature, right? We're generating a signature after signing it, right? We're generating a signature after signing it. We're using this particular key to sign this and generating a signature. Now, this signature is what we can store on our website. So let's say I want somebody to download auth.txt, but I also want them to verify its provenance. So they can download auth.txt, download the signature file, use Cosign to verify the blob with both the file and the signature. So what this is going to do is it's going to, so far we're going to just sign the thing. So you'll see that less auth.txt.sig. You'll see that there is this base64 encoded value, which is the signature, which is now for that particular binary auth.txt. Now let's verify this. Right now, this is cool because this is much more than a hash. Uh, it's much more significant, much more robust than compared to hash. You'll be thinking, what is the difference between this and a hash? And the difference is that it's first of all a signature, which is very different from a hash. Hash is just you taking the content of the file and generating a hash value. Now, if somebody changes that file and changes the hash value entirely, there is you really have no way of proving that Abhay did that, or somebody that you apparently trusted or you thought you trusted did that, right? So that's something that you don't really have with a plain old hash. Whereas with the signature, first of all, it's a public-private key pair, so it has to be signed with a particular private key to be for you to be verifying it with that public key. So let's verify this. Verify blob. So let's do that, right? So what we're going to do, if you look at the verify, you'll see that the verification really happens in a two-step way, right? So you're not on, you're essentially saying that, hey, you know what, the signature is in this sig file, which you've downloaded from somewhere. And the file I want to verify is this auth.txt file. So do this operation for me and tell me whether the file is genuine or not. And when you do this, you will see that it verified. Okay, right? It gave me a bunch of warnings because they have removed the single dash notation. But nevertheless, it verified okay simply because it was a valid file with a valid signature or whatnot, right? So if we change the contents, so in .txt, this is super sensitive, and yeah, so you'll see that failed to verify the signature because obviously the signature didn't match because the original content of the file didn't match. Now, if somebody were to deal with, so let's say somebody compromises your website, changes the TXT, changes the hash, then in a scenario where they're just doing plain simple hashing, it's not really useful simply because they have this constraint that they're dealing with. Now, with this, it's really much more powerful because it's linked to a key pair. And since it's linked to a key pair, it's much more robust. And the cool thing about this, and this is something that is underrated when it comes to the benefit of using something like Cosign, is that it's very easy to, I mean, it's very easy for you to run this as part of a build system, as part of a CI/CD pipeline, because you don't have too many you don't have many user inputs, right? You, in fact, that other than the fact that I had this password to be entered, which I can do even in a CI/CD system, there is nothing else, right? It's very easy for me to validate. I wget this and wget this and verify this with the verify blob, and it's done. I don't need to do anything else. That's really powerful stuff, and I think they've really thought about this very deeply when they're actually going about doing this. So I really like the thought that has gone into this particular process, right? So this is Cosign for blobs. So we've looked at container images, we've looked at blobs. Now you have a whole bunch of other things that you can do as well. You can attach an SBOM. Like I said, you can download an SBOM, you can attach an SBOM, you can do all of those different very interesting things because they've realized that integrating it with different parts of the supply chain problem makes a lot of sense as well. So you actually have a lot of different things that you can do with this. Now, the other thing that I'm hoping to do a demo of, I've not tested this before, so please forgive me in advance if it doesn't work, but I'm going to give it a shot, is basically using Vault to as a key management system. So managing keys are obviously going to be a pain, right? So we all know that managing keys is obviously going to be a pain. There is a way out in terms of Cosign because they have keyless, but a lot of times, let's say you don't want to use keyless or you have existing key management system, you can integrate with several key management systems, right? So, and Vault is one of them. AWS KMS is one of them. GCP is one of them. So you have a whole bunch of key management systems that they support. So I'm going to be looking at an example where we are going to be using a key management system like Vault, where I have generated a public private key pair to be able to actually check this out. So let me just do that. Give me a second while I pull this up. And I have set up Vault. It's running on my local machine. I'm running it in dev mode. So uh, obviously dev mode is not something that you want to be using for prod use cases, but since I'm just doing this as a an example, that should be fine. Just give me a second. Yeah, so this is something I'm not 100% sure whether I actually am doing this correctly. Um, I've generated a Vault PKI, I've done the certs. Okay, all right. Okay, so actually we have Vault running and we've enabled the PKI mode and we also have initialized a certificate, an internal certificate for example.com. Now, just give me a sec. Let me just try and find it. I had this in my notes somewhere. Just checking out where that is. Yeah, it had a Hashi Vault. Internet key pair. Oh, okay. Okay, so I don't need to do much actually. Cosign, the generate key pair thing allows you to do that. So this provider also requires, okay, Vault enable transit. Vault enable what transit? Secrets. Okay. Vault enable secrets transit. Vault secrets enable. Vault secrets enable transit. So I need, yeah, so it needs the transit. I think it's going to store the key with the transit namespace. So Vault has different namespaces to do different things, right? So it has the key value namespace that allows you to store secrets like passwords, API keys, and things like that. It has the transit backend or the transit secrets engine to store symmetric keys and so on. You can also use Vault as a as a certificate authority, which is what I try to do. But I don't think you need to do that for Cosign. So Cosign should be able to interact with Vault without having to do that as a certificate authority. I think that's how it should work. Just give me a sec while I figure this out. I had this documented somewhere and I actually used it at some point in time, but I've forgotten how to do that. Oh, okay. Oh, yeah, got it. Okay. So let's use Vault and generate something. So Vault Cosign generate p pair dash dash KMS Hashi Vault, which is so it uses URI notations like this Hashi Vault, AWS KMS, GCP KMS, and stuff like that to be able to actually do the whole integration with these tools, right? So they will talk based on the underlying machine's configuration and whether it's configured to talk to Vault and so on and so forth. They'll be able to do that. So let's just so AppSec. So we have a public key written here. So you'll see that previously we generated both a private public key pair, but Vault now is managing the private keys. So you don't get the private keys, you only get the public key. So if you look at the cosign.pub, this is the public key for the corresponding private key that is in Vault. Now, this key is stored in using symmetric encryption. So since they're using transit, they're not using Vault's certificate authority capability. I thought they were, but apparently not. So they're using transit. So they're using a symmetric key to protect the private key that has been generated from here. All right. So now if I do cosign sign, just the same thing. I'm gonna sign my container image, key, hashi vault, AppSec key, and I'm going to do E45. So this is just going to sign that for me, and it's going to push that to my Docker hub, right? So this is pretty straightforward. Now, cosign triangulate E45. Last. So you'll see a whole bunch of different, I think, new Docker images. You'll see probably a whole bunch. It's the same image because the image underlying image is not changed. So you'll see that a few seconds ago it's the same. All right. So now let's cosign verify -- key hashi vault, or is it just cosign.pub? Actually, I think we need to use hashi vault. AppSec key 345 well, last. So this would verify the key just the same. You'll see that all the certificates, I mean, the claims validated, signatures validated, stuff. So this is really powerful because it's really easy, as you can see. They've made it. I like the fact that they've used the transit endpoint and not the CA endpoint, because the CA endpoint ends up being a little more complicated. You have to issue root certs and intermediate certs and handle all that jazz, right? Now, instead of that, they've used transit, which I liked the approach they've used. I didn't realize that they'd done that. The thing with transit is that it's symmetric, right? And Vault handles all the heavy lifting in terms of the key management and things like that, which is nice. So what they've done is they've used symmetric encryption. I think I need to read up the docs a little bit more. I think they've used symmetric encryption to be able to store that private key, or to be able to wrap or encrypt that particular private key. And when it's used, it's only then I think it's decrypted, and then the private key is decrypted, and that private key is used to sign, and of course the corresponding public key is used to verify the key. So I like that they've made these design choices to use Vault this way. This is actually very interesting because this is faster. Because otherwise, if you have to use the CA thing again, you're running into the same constraint that was there with CAs that organizations deploy as well. So I like the fact that they've done it this way. And this way, it's much easier to set up access control policies on Vault as well for you to be able to actually scale this up pretty quickly. So you can just use the transit backend, have access to X number of keys. So let's say this application or this particular application team is using this particular key for container signature. They only have access within Vault to do signature and verification based on that particular key. So I like that they've used transit instead of the certificate authority approach for Vault. So that's a really nice thing that they've done. So, like I said, the other thing that I'm not going to be able to demo is the keyless thing, because the keyless thing, you need to have OIDC enabled. And I think that's still experimental as far as Cosign is concerned. But that's really nice, because the thing with that is that they've gone on the basis of identity there. They've essentially said that, look, when you're doing this keylessly, you essentially, if somebody wants to verify a signature, they want to verify that this person or this entity signed at this particular time, right? So that's great, because keylessly that is possible, because it generates the short-lived key, and it generates the signature, and that signature is append only written into that transparency log. And somebody can just query that transparency log and say, hey, is this signature even there? Did this signature happen with this person at this particular time? And they can actually validate that and check whether it actually happened. And since it's backed by OIDC identity, it's pretty strong, because the guarantees of OIDC identity, especially for providers like Google and things, are pretty strong. So I really like the way they've done with it. And in fact, they've taken it one step further. In fact, what you can do is you can say that in dev, two signatures of two of these people need to match. Or in prod, four signatures need to match. You can actually set up very complicated, fine-grained, granular policies that allow you to control what kind of signature makes it to your production or your critical environments. So that I thought was very interesting, very well thought out by the Cosign team. So that's something that I have as well. All right, I think that brings us to the end of this particular stream. I hope you enjoyed it. This was a little quicker for my typical streams, but I'm just covering a very small area, and I myself am discovering this. I will come up with more if I find more to go on in terms of this as well. But I really like this because I find this to solve a lot of problems that are in the container and generally in the supply chain security space. And I like the fact that they've made certain design choices that make things easy for us as developers rather than trying to make us jump through a lot of hoops. And at the same time, it's backed by solid security guarantees. So I like the way they have handled this. So yeah, that brings us to the end of our show today. Thank you so much for joining in. We are going to be March 10th is going to be another show. Sharath from our team is going to be showcasing some interesting Azure exploits. So if you're interested in that sort of thing, you should check in on March 10th. If you're not part of the Discord community, we will post a Discord link that's going to be valid for like I think a week after this telecast on the YouTube description as well. So check out the YouTube description. If you're interested in learning hands-on a lot of this stuff, check out AppSecEngineer because I can tell you we're coming up with a lot of new courses, new playgrounds. We're coming up with something called challenges. It's going to be a lot of fun if you want to learn and get level up your skills in AppSec with AppSecEngineer. All right, that brings us to the end. Thank you very much. Have a great day. Have a great evening. Have a great night, depending on where you are. Ciao.